Okay, now we look at question number 9. You can refer to your paper. Okay, the rate of increase. Now we are talking about increase in the number of species of a fish in a lake is described by the differential equation. Okay, you are given this equation. And then P is what? P is the number of fish at time t. Therefore, if you look at the graph, that means P is the number of fish, T is the time. So you are given, that means this is P and this is T at this time. Of course, they will give you the general one. They don't give you when T equal to 1 or T equal to 2. That one is only true for that particular time. So definitely you were given a general one. Okay. Now at time T, weeks are now the T is week. Remember that. Okay. A, the rate of reproduction, and B is the mortality rate, where A and B are constant. So remember, the fish will reproduce. Okay, so you see, look at this diagram. You are given dP over dt is this, and then you see that reproduction rate is A. So that is how fast in 1 week they can give birth. And then at the same time it will die also. It's negative B. It will die at negative B per week. And then actually the equation should be like this. Okay, the equation it should be like this without the P here. It should be A minus B only. But why we have a P? Because we have to follow the question. The question never tells us why, so we just follow. Okay, we have to follow. And then after that, this is a separable variable. Okay, separable variable. So you solve it. Okay, and then now we read again. Assuming that the part 1. Okay, part 1. Assuming that P equal to P naught at time T equal to 0. That means that is the initial condition. When T equal to 0, P is P naught. This is the y-intercept for us to find C. And then A is always greater than B. That means they will give birth faster than die, so that the number will increase. If let's say B bigger, then it will die faster. Then finally, all the fish will disappear. It will extinct. Okay, solve the above differential equation and sketch the solution curve. So we are going to solve. Okay, so now this is what you get. Okay, after now I'm going to find the C. I just substitute T equal to 0, P equal to P naught. So I substitute here. Okay, you can go through this C ln P naught. Then I substitute back the P naught. Then I solve this. Finally, I will get, you see, this is the exponential curve. That's why you see all the natural phenomena, when increase is exponential, decrease also the exponential. That's why exponential very important. Okay, then we are going to sketch the graph exponential curve. So we use this table. Then you have this. This is the curve. Okay, this is the curve. But of course this is not, because this is positive. So this is the curve you get. Okay, this is the curve. Okay. Okay, now we go to the second part. This is the curve. T is in week. Okay, now we go to the second part. At a certain time, there is an outbreak of an epidemic of a disease. The epidemic results in no more offspring of the fish being produced. That means the fish, this epidemic will cause the fish cannot reproduce anymore. And the fish die at a rate directly proportional to this. Okay, there are 900 fish before the outbreak of the epidemic, and only 400 fish are alive after 6 weeks. Determine the length of time from the outbreak of the epidemic until all the fish of that species die. Because when we have these epidemics, all the fish cannot reproduce, they only die. So it will finally become 0. All the fish will die. So how long all the fish will die? Okay, now we look at this. Look at the graph, or look at this. You see. Come back to this. Okay. Here, this is the reproduction rate, and then the epidemics. Because of the epidemics, they cannot reproduce, 0. And this is the rate. How fast they die. Actually, how fast they die just now is negative B, isn't it? This is negative B. And then they said this negative B is proportional to this. That is the rate. You see, the rate the fish die at a rate directly proportional. That means here means the negative b proportional to negative square root 1 over p. Okay, so that means you have, after that you have this. Negative b will be equal to negative k square root 1 over p, isn't it? Therefore your b will be this. Okay, so this is your b, because this is the mortality rate. Okay, the mortality rate is proportional to this, is given in the question here. Okay, so you have b equal to this, and then we form the equation. The equation is just like just now, dp over dt is this one minus this one times t, because this type of fish, they will increase, follow this. Okay, our given in the question. Okay, so our a is 0, then the b is this, substitute, then we simplify, you get this. Again, it's a separable variable, then we solve this separable variable, we solve it. Okay, bring it over, then we integrate. Okay, we integrate, you get this. Okay, look at the graph here. Here, just now, what is given? You said there are 900 fish before the outbreak of the epidemic, and only 400 are alive after 6 weeks. That means, you see, here got outbreak already. We have 900. So you have 900 fish here, then outbreak, the epidemic. And then after 6 weeks, t is big, you have only 400 left. Okay, so the question is, determine the length of time from the outbreak until all the fish die. So from the outbreak here until all the fish die, that means p 0. So how long it takes for all the fish to die? Okay, so we find from here. This one we integrate. Okay, you get this, then we substitute. T equal to 0, P equal to 900. Substitute, you get C equal to 60. And then here you can find K. Usually this is find C. This is, I told you already, y-intercept. This one is for us to find K when you give the extra one. So T equal to 6, P equal to 400. You see, when I substitute, you see, when I substitute, you see I can get K, isn't it? So this one for you to find K. This one for you to find the C. Okay, then I show you C and K. Okay, then after you got this C and K, you put back into our equation. 2 square root P, put in the K, put in the C. And then when all the fish die, you know, when all the fish die, we come back to the graph. When all the fish die is here, P equal to 0. So we substitute P equal to 0, we find the T. So I put T equal to 0, I find the T, I get T 18 weeks. That means answer is 18 weeks, all the fish will die. Okay, so you can try all the page one I give you.